correct answer why we are using. Okay, so I might when taking that time. Let's just wait. Next question. That is principle of machine. All right. So we come to the principle of machine. Principle of machine is basically uh, is a principle which is uh, used to differentiate between your ideal machine and your actual machine. Now we all know that according to the law of conservation of energy, energy can either be created or be destroyed, but can be transformed from one form of energy to the other. So in a simple terms, we can use say that whenever we are doing any work, we are trying to input some energy, and some energy we are getting it in form of output work. Okay, so when the energy is supplied to a machine by applying the effort, okay, it overcomes the load by doing some useful work on it. This is a statement taken from a book itself. Okay, very nicely it says that energy output is all should always be equal to energy. Okay, so for an ideal machine, we say that energy output or output energy should be equal to input energy. All right. So whatever energy has been input onto the machine, the same I should get it as an output. Okay, and therefore we consider that output energy should be equal to input energy. Uh, it might be same like whether we write down output energy equal to input energy or input energy equal to output energy, both are same. But logically, when you see the energy which we are input, according to that we will be getting the output. So output should be equal to input. That should be a logical way of writing down this. So principle of machine says that for an ideal machine, output energy is equal to input energy. Now how to calculate this output energy? Output energy basically, or I'll use the symbol only. I use E output. So energy is basically capacity to do work. So we measure energy in terms of the work done. So this will be equal to work output. Output work. Okay. Now work output. This has been done by the machine. Okay. On the load. So this will be equal to load into the distance moved by the load or the displacement of the load. Okay. Similarly, energy input should be equal to work input, and work input is equal to the effort which you are doing. Work input is the work done by the effort on the machine. Okay, so work done by the effort on the machine, that will be your effort into the distance moved by the effort. All right, and never be greater than the input energy. Okay, and therefore if we try to calculate the efficiency, so if we try to calculate the efficiency over here, which is work output by work input, okay, so work output by work input, and since the output energy can never be greater than input energy, which means that the output work can never be greater than input work, therefore efficiency can never be greater than 1, or in percentage 100%, which I had already written. Okay, okay, so this gives rise to two type of machines. So we can now classify machines, not exactly the classification, it's basically how we perceive these machines. Machines can be classified into two categories, that is your ideal machine and your actual or practical machines. Okay, ideal machine is a machine where we find there is no loss in energy, no loss of energy. As there is no loss of energy, so what will happen? Work output will be equal to work input, and since work output is equal to work input, so the efficiency will be equal to 1 or 100%. Okay, so an ideal machine can be defined as a machine in which there is no loss of energy in any condition, that is work output will be equal to work input and efficiency is equal to 100%. Ideal machine is practically impossible. Yes, you can have an efficiency close to 100, close to 1, okay, but it cannot be equal to 1. I'll just explain why. Let's come to the actual machine. So actual machine is the machine actually which you are using. Okay, so there you will find that there is a loss of energy taking place. Okay, now when there is a loss of energy taking place, so what will happen? Work output will always be less than work input, and since work output is always going to be less than work input, means effort you are applying or you're doing more work, and the result we are getting it as less work. Now this might create a confusion to you. Okay, and as a result the efficiency of the machine is always less than 1 or 100%. All right, so this is how we define the ideal machine and the actual or the practical machine. Okay, now why we have got this difference between the actual machine and the ideal machine? So what is the cause? Do you have any question? Just before I causes. Let me see if you have. So if it is asking you, Anshika, if it is asking you the efficiency, it depends upon the question. Generally in a question, what we do, if it is not giving you the machine as a efficiency is not been given, okay, then we consider it as an 100% efficient machine. Ideal machine we are considering, and we calculate the percentage as it is. Okay. Otherwise, we'll see the conditions, what the conditions have been asked in the question, and accordingly we do. So whatever the value of mechanical advantage and your velocity ratio is given, or work input or work output, based on that we will be calculating the efficiency. So I hope, Anshika, your question is clear. Okay. Efficiency is so sir. Yes, you're. See, whenever the machine, Kana, whenever the machine is been given, okay, it's mechanical advantage and velocity ratio. So for a velocity ratio, it remains constant for a given velocity ratio. Mechanical advantage can alter. We'll see it in the few examples when we will study about the machines. We'll see how the mechanical advantage is going to change and velocity ratio remains same. Okay, so accordingly we will be doing it. Yes, Mayank, we cannot have 100% efficient machine. We can have the efficiency of machine maybe up to say 99.9999 as much. Okay, we can reduce the energy consumption, or we can reduce the dissipation of energy, say for example by using the lubricants and other things. But still, we find that we cannot reduce it 100%. Few things we are not able to reduce it to the 100%. Yes, ideal machine, we will be having mechanical advantage equal to velocity ratio, but it is not always. Okay, there are certain cases where we find that your it's used for turning the forces and changing the direction. We might be having the mechanical advantage and velocity ratio equal to 1, which means that it is 100%. But generally, actual practice, we will not be having 100%. Okay. So whenever you are calculating it as an 100%, or the value is coming as an 100%, keep in mind this is a theoretical value. Practically, we will not be getting this. I hope, Ashutosh Ranjan, it's clear. See, Nanika, when you are asking that energy input is equal to energy output, will it be wrong? See, logically it is wrong. Okay, because when we are doing some work on the machine, then the machine is giving us an output. Okay, so your input cannot be equal to output. Your output will be equal to input. Okay, so that is why the logical, mathematically both are right. Okay, but logically when you think, okay, you cannot have the machine output as equal to machine input. Machine input will be machine output will be equal to machine input. The energy output will be equal to energy input. uh, when you go to the outer space theorem, okay, you find there are a lot of changes in the physical phenomena and the physical principles. Okay, a very simple example, that the way you are behaving on the earth. Okay, simply you are eating, and when you are eating a food, it is going into your stomach. You may not be able to understand, or you might be knowing it. It's only because of gravity, and as soon as you leave the gravity, okay, the things are not the same. What you think in a normal way is not going to behave as a normal way. Okay, for example, the astronauts, they have to be trained for each and every activity. Okay, uh, so outer space, the things are different, the principles are different, the forces are different, and therefore it is not going to be in the same context. Why, Manaswin, why you want to say that clock is an idle machine? In idle machine, yes, there is no loss of energy. Yes, Devesh Pandey. Uh, in idle machine, we say that there is no loss of energy. Yes, that is why we say it as an idle machine, which is practically not possible. And Manaswin, as per your question for can we say clock is an idle machine? Uh, See, none of the machine we can say it as an idle machine. Okay, because in case of the clock also, we observe that there are so many parts, okay, which might be undergoing the loss of energy, and therefore you cannot have the clock be said as an idle machine. Practically, idle machine is not possible. Okay, at least at this level. Okay, so now we move to the okay. Now we try to see the causes which are responsible for an loss of energy, or why can't we have an idle machine? Cause for the loss of energy, or why a machine cannot be an idle machine? Now, there are three major causes due to which the machine is not considered to be an idle machine. Okay, the first cause is that the moving parts in the machine are neither weightless nor smooth. Machine are neither weightless nor perfectly smooth. Smooth. Okay. If there is any string being used, it is not perfectly elastic. If any, is not perfectly elastic. And the third reason is that its different parts are not perfectly rigid. Different parts are not perfectly rigid. All these things basically give rise to a force called as friction. So most commonly, with all these factors, we find that there is a lot of friction taking place between the parts of the body, of the machine, sorry. Okay, and due to the friction, so the machine, the different parts of the machine has to overcome this frictional force, and that is why whatever work is done on the machine, that is the work input, some amount of work is being utilized to overcome these frictional forces. Okay, and in certain cases, you will find that the major portion of the work input is utilized to overcome these frictional forces. As a result, what we find is that the efficiency of machine decreases. So when we say the machine is 80% efficient, 80% efficient means only 20% is being utilized to overcome these frictional forces. Sometimes you will find that the machine is only 40% efficient, which means that a major portion of this is going to be utilized to overcome the frictional forces. Now, how can we make out that? It's basically whenever you use any machine, simply you take a hexablade. Hexablade, I hope all of you know, you might have seen the masons or the laborers been cutting the iron rod using a sort of blade, or even a cutter can be set, or any, even you take a small, you take a knife and then try to cut a bit hard vegetables and fruits. When you are cutting, that is soft, so you cannot experience that. But say suppose if you are taking a PVC pipe and try to cut through this, you will find that it gets heated up. Okay, the heated up portion is because the amount of energy, the work which has been done, that is getting converted into your heat energy. Now the purpose of the knife was to cut the pipe, but now here we are not able to cut that. Okay, or rather it is not cutting as smooth as it should have been, because some amount of work has been done to overcome that. Even in case when you are cutting the vegetables, or whenever you are cutting the fruits, there also you will find that you have to apply an effort, and some amount of effort is been utilized to overcome the frictional forces which are coming while cutting the fruits or the vegetables. Okay, similarly, an engine, say a car, when you are starting, you'll find that it gets heated up as it works. Okay, you might have seen, if you have got a mixer and grinder, or sometime even in the vehicles, you have to change the ball bearings. Okay, because they are not perfectly smooth, or with the time passage of the time they are worn out. Okay, in case of a mixer grinder, if you see the lower connecting points, okay, where the motor is fitted and the jar fits over it, it will be having grooves. So what happens if you don't set them, or even if you set them, you will find that these grooves keep on trimming itself, which means that the parts are not perfectly elastic. Even in case of metal parts, you will find that they will be they have to be changed after certain period of time, because the shape is not maintained, which means that their shape is continuously changing, which means that they are not perfectly elastic. And with the passage, or with the usage of the machine, we are trying to, or rather some part of the work which you are doing it as an input is being utilized to overcome this frictional force. And the major change in the energy which is taking place, that is in forms of heat and sound energy. Okay, so these are the basic cause for a machine not to act as a ideal machine, and therefore the machine which you are using, that is going to be used for as an actual or a practical machine. So I hope the reason is clear to all of you. If you have any question. No, knife is also not an ideal machine. Its friction will be there. So I hope something is clear to you. As I told you, that they are not perfectly frictionless, okay, although they reduce the friction considerably, but because they have been continuously been used, so what happens, their shape changes. Okay, slight change in the shape will increase greater heat production, which means that the loss of energy will be taking place more, and that is why after certain period of time we are required to change these ball bearings again and again. I hope Yashita is clear. When we can use the heated knife. Okay, the heated PVC is basically a plastic. So when you are heating it, when you are heating the knife, okay, you are increasing the temperature, which will melt the plastic, and it will be more easily to cut. talking about an actual machine and your ideal machine. Okay, machine and the actual machine can be more closer to the ideal machine. But when we say ideal machine means the efficiency should be 100%. Okay, which means that work input should be equal, work output should be equal to work input. But actually, when you calculate it, okay, how smooth it is, how fine it might be, appear to be, but it cannot be all 100%, and therefore ideal machine is never possible. So I hope Alok it's clear. These are friction. As much you decrease the friction, the efficiency of the machine is going to increase. Needle is a machine. Yes, needle is also a machine. Ratish. Yashita, it's basically it's the knife gets heated up during the cutting of any hard thing, because when you are cutting any hard surface, the work input which you are doing, due to the friction from the hard surface, we find that it gets converted into your heat energy also. Okay, so mostly it gets converted into your heat energy, but it's not only the heat energy, it may get converted into your sound energy also. Hydraulic system, see, if you are talking about an idle machine, none of the machine is an idle machine. Okay, so I hope too many questions. Let's move to the portion. Otherwise, I will keep on answering your question only. I'll answer them a bit later. Okay. So we move to the next part. That is relationship between the efficiency, mechanical advantage, and to the next part. In this part, we will be dealing with the relationship between the efficiency, mechanical advantage, and velocity ratio. Efficient, I'm using the symbol only. Mechanical advantage and velocity ratio. All right. Now let us consider a machine, okay, which overcomes a load L by applying an effort E. Okay, so effort applied on the machine, let it be E. This effort is used to overcome the load, let it be L, and this is taking place in time T. Now when we are applying an effort and the load, let the distance moved by the load be dl. Load be dl, and distance moved by effort be dE. So now we will calculate the work input. So what we have, once again I'll repeat it, we are considering a load L and an effort is been applied, an effort E is been applied in the same time T, and when the effort has been applied, we find that the distance that is moved by the load is dl and the distance that is moved by the effort is dE. So mathematically, if we try to express this, so we'll try to find out the work input, that is Wi, that will be equal to the effort into your distance moved by the effort, whereas work output will be equal to the load and the distance moved by the load. This we have done it in the earlier portion also. So this is work input and work output. Now applying the definition of the efficiency. Now we all know that efficiency is equal to work output by work input, and therefore if we put the values, that is work output is L into DL and work input is E into DE. Okay, this we can write it also as L by E into DL by DE. Now we all know that L by E is your mechanical advantage, whereas dE by dL is your velocity ratio. So this we can write it as 1 upon VR. Okay. So now we can write down efficiency is equal to MA upon VR. Very simple relation derivation we have. It is, if the work input and work output is clear, then this is very simple. You should learn this derivation. Not most of the derivations are not there in your syllabus, but this derivation is there. So you please go through, quite often it is being asked. Okay, so you can go through this. So efficiency can be written as the ratio of mechanical advantage to the velocity ratio. Okay, or you can also express this, as mechanical advantage is the product of velocity ratio into your efficiency. All right, this gives a relationship between the mechanical advantage and efficiency. Now let us consider the cases for the ideal machine and your actual machine. Okay, now with this relationship, that is efficiency, mechanical advantage or efficiency is equal to mechanical advantage by velocity ratio. For ideal machine, okay, your mechanical advantage should be equal to velocity ratio. Some of you were asking. Yes, in this case, if the mechanical advantage is equal to velocity ratio, then we find that efficiency will be 1 or 100%. Efficiency will be 1 or 100%. Okay. Now, for actual machine, your mechanical advantage is always going to be less than the velocity ratio. You all find that velocity ratio cannot be, mechanical advantage cannot be greater than the velocity ratio. Velocity ratio for a given machine is generally constant. So we find that the mechanical advantage is going to be less than the velocity ratio, and in that case, efficiency is equal to, or rather, it is going to be less than 1 or 100%. So for actual machine, mechanical advantage will be less than the velocity ratio, because if mechanical advantage is greater than the velocity ratio, the machine will be having an efficiency greater than 1. Okay. Now, when we say mechanical advantage is greater than the velocity ratio, okay, and the machine is having a greater efficiency, it means that the work output is more than the work input, and in that case we will say that the energy input is less and energy output is going to be more, which cannot be the case. Okay, what I'm trying to explain you is just these are the two conditions for the actual and the ideal machine. Now I consider a case, okay, I'm considering a case where I say that mechanical advantage is greater than the velocity ratio. Okay, now mechanical advantage is greater than the velocity ratio, then what we will have? We will have efficiency is going to be greater than 1 because the mechanical advantage, that is numerator, is more than the denominator, hence the value of the ratio m by v, ma by vr will be greater than 1. Now I say that the efficiency is greater than 1. Now, efficiency is greater than 1 means if I write efficiency equal to work output by work input, and we say that efficiency is greater than 1, which means that work output is going to be greater than work input. And if I say that work output is greater than work input, okay, then what will it mean? It simply means that energy output is going to be greater than energy input. Now, we all know that energy can neither be created nor be destroyed. But when we say that energy output is more than the energy input, then the law of conservation of energy is violated. Law of conservation of energy gets violated. Okay, because energy can never be greater than energy output can never be greater than energy input. Energy output is greater than energy input, which means that some energy is being created from side within the machine, which cannot take place. So I hope this condition stands void. Okay, so we do not have a condition, or we cannot have a condition where mechanical advantage can be greater than the velocity ratio. Okay, so I hope this is clear to all of you. In case if you have a problem, you ask through the chat. Is an integral property of the matter, and therefore we cannot reduce the friction to 100%. Mayank, I hope it is clear to you. Then don't we get 100% efficiency in solar panel used in satellites? 100% we never get anywhere. Okay. Yes, close to 100%. Even if it is 99.999%, okay, we consider that okay, nearly 100%. Yashita, where what gets converted into sound? Yes, work input, work output. Say for example, if you are using the knife and you might be able to hear some sound, so that is getting converted into sound energy. Yes, sir. Right. We write down to express